All right, let's talk a little bit about this TrigStar test that we've got. This is a timed exam. You have 1 hour to take it. The person that gets the best score wins the cash prizes. There's top 3 people win cash prizes, and you get, and if it's a tie on the top score, then it's whoever turned it in first. We want to be super, super particular about our rounding, because if you're off by 100th, you get 0 points for that, so there's no partial credit. You got to know what you're doing, and on your calculator, be very familiar with your calculator. So let's jump in and let's just try some, and I'll talk along the way. So in this case, they tell us that AB, we are given that AB is 39.39, and we know that BC is 82.56. And so if we look at what we're looking for, they want the distance of AC. All right, got that. That's just a quick little Pythagorean Theorem problem. And then it also wants the angle measurement for angle CBA. So this is the other thing. Maybe I'll do this. So this is AC, that's one of the things I'm looking for, and this angle right here is the other thing that I'm looking for. So I'm going to start with my AC. I'm going to do a quick little Pythagorean theorem. Not going to show a lot of work here, because ideally you can do this without much thought. 82.56 squared minus the 39.39 squared. And then you square root that. Now, you have to pay attention to this right here. This is what's going to be on the test, that same notation. So our distances, we're going to round to the nearest hundredth. So that's going to be a 72.56. Now, I do need to keep that full value. Well, in this case, it's a pretty simple problem. I'm never going to use that again. Well, I might. I guess I could if I wanted to. But if you ever use that number to solve the next part of the problem, you can't use the 72.56. You've got to go back to your calculator using the full value. All right, let's go do that angle. I'm going to be looking for an angle, so I'm doing inverse something. I would lean towards using the values that were given rather than my rounded value. So from my angle, it looks like we have adjacent and we have hypotenuse, so that's an inverse cosine. So cosine of angle B is going to be adjacent, the 39.39 over the 82.56. So this is where you do second cosine, and then you put in that fraction. All right, and I have a 61.5 degree angle. Now, here's the thing. This is maybe new. We don't usually do this. Like on math Excel assignments, we don't have to do this. But they want the angles measured to degree, minute, seconds. Hopefully you remember how to do that. You can do it in your calculator. Some of the nicer calculators will convert that for you. If your calculator does that, that's great. If not, then obviously you just know how to do that. So I'm going to take my answer, and I'm just going to go to that second apps button, which is the angle button, and that's where it will convert to degree, minute, seconds. Otherwise, you're going to have to take the decimal point part, the decimal portion, times 60, and then take the leftover decimal part times 60 again to convert. In the end, I have 61 degrees, 30 minutes, and then it says round it to the nearest second. So don't give me any decimals on that second. You round it off to the nearest second, and that would be 12 seconds. And there's our answer. All right, so this is the second problem. And remember, these first few problems are always identical. They just change up maybe what you're looking for, or certainly the number values. All right, so you have this picture. It's a triangle. They drop the altitude. That creates 2 little right triangles when they do that. So you can do some SOHCAHTOA in there, maybe some Pythagorean Theorem, because you have right triangles. Now, what I have done on this, I went ahead and marked what was given to me. This 46.15 was given. And then this angle here is the full angle F. Notice how it's GFE. So what I've done is they have it in degree, minute, seconds. I've converted that into a decimal value. And then what I did with that is I stored it in my calculator as F. Anytime I want to use that number, then I'm going to do alpha F to get that number. That's just my way. You may not want to do that, but I just do it because it saves me having to scroll up to go grab numbers constantly. All right, I did the same thing with angle E down here. All right, so let's get started. The distance EH is what we are looking for. So that's this length right here. And what I'm going to probably do, since I also have this length and I have this angle, I'm going to do some SOHCAHTOA on that. Let's do, looks like it's going to be a cosine. So I'm going to start way up here. I'm going to say, and this is me finding EH. I'll try to keep this a little bit organized because it can certainly get messy. So to find EH, the cosine of angle E, which I know and I have stored as angle E, is equal to adjacent, which is what I'm looking for, EH, over 46.15. All right, let's go solve that real quick in our calculator. So I'm just going to take my 46.15, I'm going to multiply it by the cosine of alpha E. And EH then would equal 33.4. Well, they want it, okay, and they're going to want this rounded to the nearest tenth, so, I'm sorry, to the nearest hundredth, so that's going to be a 4,4. So I will put 33.44 here as my answer, but again, I don't know on these always if I'm going to need that number again, so I'm going to start storing stuff. I'm going to store that, I guess, as a Z. How about that? So right now, while it's sitting in my calculator, I'm just hitting store alpha Z, just in case I need to use that number again. All right, the next one I'm going to do FH. So on FH, oops, I shouldn't have probably done that highlighter business. That's going to get messy. FH, well, that's just a different side of that same triangle, isn't it? So let's do that one. This time, again, I like to use the things that are given to me, so I'm going to use the angle E, I'm going to use the 46.15, so this looks like a sine situation. The sine of E is equal to opposite, which is FH, over the hypotenuse, which was given to me as 46.15. So in my calculator, sine alpha E times that 46.15. I'm going to go ahead and store that as Y. Maybe I'll never need these, but I just don't always know, and it just saves me time later while it's sitting in my calculator. All right, let's look at the next problem. We're looking for FG. That's a different side of this triangle. Now we're over here looking for this, which is in this right triangle. Now we now know this length right here. I don't know, you tell me, I guess, maybe, I mean, I could look at the full triangle, but the full triangle is not a right triangle. So that would lead me towards law of sines and cosines, which is certainly a fair option. But since this is a right triangle, sometimes I'll lean towards doing something there. I guess a lot of the time they'll have you work through this in the order that you need it, but I noticed down here later that I'm going to need to know angle EGF, that's this angle down here. And that's actually, I don't know why they put that at the very bottom. That's a pretty easy thing to find because in the big triangle, I already have the other two angles. So I could subtract those. And then once I have the angle G, I could just be doing some SOHCAHTOA in here. So I think I'm going to go ahead and work ahead, and I'm going to find this angle. And so I'm just going to take 180, and I'm going to subtract alpha E and subtract alpha F. And I'm left with a 16.08. But remember, and I guess I'll go ahead and I'm going to store that as, I'm going to call that angle G. So I'm going to store that as G. But I can't write it. And remember, I'm going to have to take that times the 60, and then take it times 60 again, or do whatever your conversion preference is. All right, so here I go. So I've stored it as alpha G, so I have that part done. And then what I'm going to do is I'm going to subtract 16 off of that to get the decimal, and then I take that times 60 to get the minutes. So I'm at 5.3 minutes. I have 16 degrees I have 5 minutes, and then I'm going to subtract off the 5, so I just have the decimal part, and then I take that times 60 again to turn it into seconds. Looks like, and remember we round off entirely, so it's 18 seconds. Now what I'm going to do is I'm going to go back to this FG that I was working on. FG was up here. I'm going to look at this right triangle because I know FH, I found it right here. I have FH, that's opposite of angle G, and I'm looking for hypotenuse. Opposite and hypotenuse, that's going to be sine. So sine of angle G is going to equal opposite, which is FH, which I already found is my Y, over what I'm looking for, which is FG. This is, looks like what I'm going to have to do is I'm going to have to multiply. If you think through this in your head, and some of you can just do this, multiply by both sides by FG, but I don't really know what FG is yet. And then I would come back and I would divide. So it looks like FG is going to be Y divided by the sine of G in my calculator. So alpha Y divide by sine of G. And I got 114. Point, looks like 79 is what that would round to. All right, now I could store that, but I'm just kind of looking ahead. The next thing I need to find is GH, which is this, which is still part of that same triangle. I'm not going to mess with storing it because I'm going to ultimately kind of do the same thing I just did. Here's angle G. I know opposite from earlier, and I'm looking for adjacent. That's a tangent problem. So here we go. This is finding GH, tangent of angle G, which I do know in my calculator, is equal to, and I am going to do opposite, which is FH, which I know is Y, over what I'm looking for, the adjacent GH. So again, if you can do that in your head, that kind of hurries up the process. I'm going to multiply both sides by GH, come back and divide. So GH is going to equal Y divided by tangent of G. So in my calculator, I get 110 ish, and then I'm gonna I have to convert that, so that's 100 and I guess I'm sorry, I'm not converting. It's 110.29 is what that would round to, and then I am done with this problem. Look at all the points that you get on just doing SOHCAHTOA stuff. That's all we did was SOHCAHTOA. So that should be the whole. This is all the first page. So all of that should be a lot of easy points for us as long as you're careful about your rounding. All right, this is the next page, and this one, again, is the same picture all the time and the same process. You can see I've marked everything similar to last time. I am looking for the distance AB, which, well, and if you look at the progression, it's AB, AD, and AC. So AB is this one. AD is down here, but ultimately our goal is to figure out this diagonal here. The problem that we have on this is with this particular side and this particular side, we're using this angle, which is unfortunately not an angle in either one of these two triangles. So this problem is always set up to where you need to put in what we call an auxiliary line. You're going to put in this line, this diagonal B to D. So it creates two triangles here, and I'm going to go ahead and highlight them so that I can reference then which one I'm dealing with. So I'm talking about either the yellow triangle, which is the triangle that's created, which is handy because now that uses the full angle that I want. But it might also be, let's go put in a blue one. I might be using the blue triangle, which is this one over here. Now eventually I'll probably get back and do the original triangles that were created, but I have to create this auxiliary line, and that is common for sure in the last one to have to draw in some extra lines. Now, to work on getting AB, I have to get some other work done before I can even get over to this triangle, because the only thing I know in this triangle is this angle. I got to have more info. But over in this triangle, I know two sides. And if I know two sides, then I can find some other stuff out. If you will look at the original picture, the very original picture had two right angles in it. and it had this angle right here, which I've already stored as A. Well, in a quadrilateral, like in a triangle, we know that the angles add up to 180. In a quadrilateral, they add up to 360. So to find out angle C up here, I'm just going to take 360 and subtract the two 90s and subtract angle A there that I have. So here we go. That angle is a 97.5. I'm not going to put a whole bunch of decimals here because I'm going to store that as angle C right there. Now I have 3 pieces of information in my blue triangle, so I can find anything else out that I want. I've got to work my way over into the other triangle, and so I'm going to go ahead and find BD. I could also go find some angle measurements in there, so I'm going to do that as well. Let's start off and let's do a law of cosines problem. And I'm going to look for BD. So BD, I'll go ahead and keep this blue, BD squared should equal 128.82 squared plus 68.86 squared minus 2 times the 128 number times the 68.86 times the cosine of angle C, which I have stored in my calculator right now. BD is going to equal 153.82. It's not really something they asked me for, so I'm going to go ahead and just store it because I know I'm going to need that full value later. So let's go ahead and call that Z. So in my calculator, I'm going to store it as alpha Z. And again, if you don't want to do the storing and you just want to scroll up and down, that's okay too. Whatever you're fastest at. All right, so now that I know what this measurement is, I've got the 153.82, which is Z. That's only 2 things in my yellow triangle, so I've got to find a third. And so now I'm going to go to my angle measurements. I have enough information in the blue that I can figure out some angles. I'm going to go ahead, probably since I have a law of sines, I think is going to be a little bit faster for me. I'm going to work on finding this angle right here. So I'm going to do law of sines for that one. And I'm going to have, this is finding angle D. And that's kind of a lazy name for angle D because I'm just using my color coding. So to do that, law of sines, my matching set is going to be the blue numbers. I've got Z, which is the 153, over the sine of the 97, which is I have stored as C. So if I got the letter stored, I'm just going to write this stored there. Should equal a 128.82 over the angle I'm looking for, or the sine of the angle I'm looking for. So you can do your cross products in your calculator, and we're going to look for sine of D. That's what we're searching for, so don't forget to do second sine at the end. All right, so I got a 56.13. I'm going to go ahead and store it as D. So this measurement right here, I now have as D. I can find this other one up here by subtracting those from 180. So this is angle B. I'll show the work. You wouldn't have to, by any means, show the work. So it's a 180 minus the angle I just found and minus the angle C that I already knew. Now, it never asks me for angles, so I'm not going to convert these to degree, minutes, seconds, because my official answer is the only thing that would have to have that. So I've got the measure of angle B is 26.35, and again, I'm going to store that as a B because I haven't used B yet. Now, really what I'm working towards on this, and again, these all are the same deal. This is exactly how you set this up. So you got to be familiar enough with it, you can kind of cruise through this. What I am really wanting are these angles over here. I want this angle and I want this angle. So since those were 90s, I can find those 2 angles by subtracting the angles that I found. So if I do 90 minus B, I will have this angle up here, which is a 63.65. Now I have to store that as something because that's really the angle I'm going to want. So I don't know. You can just pick random letters as long as you've been noting what they're going to be. I'm going to call that, I don't know, I'm going to go to the middle of the alphabet. Let's go with a K for no particular reason. And then I'm going to do 90. Sorry, I forgot I got to go save that before I keep moving. Store alpha K. Got it. All right, so now I'm going to do 90 minus angle D down there. And then I'm going to store that as, let's store it as L, I guess. And I got a 33.87 or something like that. And again, if you just want to scroll, have I said that enough times? Okay. This is L for me. All right, we're finally in the yellow triangle, so we've got a lot of info that we can work with over there. And I'm going to now start working on finding these measurements. So I'm going to work on AB. AB, I think I'm going to do law of sines because I've got this matching set here. Remember when you do a matching set that means that you have the side and the angle that are opposite each other. So there's my matching set I already have, and I'm going to work on finding this one. I'm also going to do AD, so then I'm going to go this way also. Some of you, maybe I'm going to try something here. Let's see how good you are. So I'm going to do a 153. Oops, actually I have that stored, so I'm going to go ahead and use the letters just to save myself later. So this is Z over the sine of A equals, I know that, let's work on AB, which is what I'm looking for, over the sine of L, which would also equal, I can kind of do a 3 in 1 here. I don't know. I mean, this is something, if you're going to start being good at this, that you can probably do all of this in one shot. And then I'm going to also be looking for AD over the sine of K. So what I'm going to use is the Z over sine A. I'm going to start with doing this proportion right here and solve for AB. And then I'm going to ignore this, and I'm going to use these two and do the same thing. And then can you kind of do that in your head? If I'm looking for this, I'm going to cross multiply and divide. So I'm going to take alpha Z times the sine of L, divide by the sine of A. And there's my 86. This is finding AB. So this is finally to one of the answers that I need. So there's an 86.48 is what I have for an official answer here. Then I'm going to do it again. And to be honest, if you're really good, then you can just go up and grab that equation you just did and edit it. So it's Z times the sine of K. And just change that one value. And you should get AD to be 139.04. Now, I'm just trying to do some things slower for you, some things a little quicker, some shortcuts, just to help whoever to kind of progress in your skill level. Last thing we have is AC, which is that diagonal that goes back to the original. Here we go. So I'm going to be working with this triangle right here. I've got this. I'm going to work with this triangle, I guess, because I have a lot of information on that. So I'm going to work with, let's see, shall we do, we know this full angle because we could just, that's a 9, well, heck, that's a right triangle. We could just do SOHCAHTOA on that. Let's just do SOHCAHTOA. So there's my right triangle. Actually, I'm not even going to do that. I'm going to do Pythagorean Theorem. Let's do that. Because I have this leg, I have found this leg, and I'm looking for the hypotenuse. And that's what I want. I'm doing Pythagorean Theorem. Here we go. So I have the 128.82 squared plus the AB, which I did not store those, so I'll have to go grab 86.48 number squared equals what I'm looking for, which is AC squared. All right, here I go, 128.82 squared. I'm going to add, go up and grab the 86 number and square it. And square root my answer. And I have a 155.16 for my final answer. All right, so you can see there's a little bit more thinking going on in this, a lot more work. So the quicker you can get with doing your law sines and cosines, better off you are. Now this next problem is our challenge problem, and so I've just written kind of what the problem was right here, and you can read through that. I want you to take a minute to look at the picture of it. You should have a copy of this, hopefully, as you're going through this with me. Look through that and see if you only have 3 things you have to find, but since it's a challenge one, there's probably a lot of stuff you have to find before you're going to get to that point. So take a peek and look at it and see what you want to do with it. Come back in a couple minutes. All right, I am sure there are many ways to do this problem, so I'm going to kind of go a little bit at a time and kind of get you going on it. The first thing they want to know is AB. So AB is this length right here, which isn't even drawn in. So then, of course, I'm going to draw it in, and I can see it creates this nice triangle when I do that right here. But I always have to know 3 things in the triangle before I can start doing law sines or SOHCAHTOA or anything. So what I do see is I have an angle here, and I have this side measurement. So I need one more piece of information in this triangle. So what I'm looking, I see angles all over the place, but I don't see a whole lot of side measurements, and I know I'm going to need a side measurement. So I'm looking at this. And I guess the thing that jumps out at me is that, okay, well, what if I look at this triangle here? Because it connects through EB. So if I could figure out EB in this triangle, then I would be able to know what EB is over here. In this triangle, that'd be my 3rd piece of information, and I could work on finding AB. So that was my strategy. So here's what I did. I went ahead and took these 2 angles here, and I just stored them all because they were all a bunch of degree, minute, second stuff. So, because I guess I should talk about in this triangle here, I have 2 angles, but only one side, and I'm looking for this side. So I would probably do a law of sines, but I needed to know W, so I would know this opposite set, and I'm going to do this opposite set. So what I did is looking again at this triangle here, I took 180, I subtracted X, I subtracted Y, because that makes that full angle, and then I subtracted Z, and what's left over is angle W up here is what I called it. And now that I have that angle measurement, I can find its opposite side since I know these opposites. So let's go do a law of sines problem here. This is me finding EB, which is, again, not even a part of what they're asking for, but what I'm going to need to get there. I'm not so sure there's not like numerous ways to do these problems. This is what just jumped out at me. So I'm going to say 418.81 over the sine of Z is going to equal EB, which is what I'm searching for here, over the sine of W. Then I go to my calculator. Here we go. All right, I got a 237. So EB is 237.47. I'm going to store that because I know I'm going to be using that. I don't know. I'm just picking random letters. I'm going to store that as V, and I'm going to mark it as V so I know that that's what I've stored that as. Now I'm going to go down to this triangle that I was working on originally, trying to get figured out this AB length. And if you notice what I have in here is I have this side, and I have this angle, and I have this side. On a side angle side situation, you don't have a matching set, so it's not a law of sines, it's a law of cosines. I'm going to do law of cosines on this, and I'm going to call this is me finding AB. All right, law of cosines, AB squared, this is what I'm looking for, this AB is what I want, is going to equal V squared plus the 546.64 squared minus 2 times V times 546.64 times the cosine of that angle. Oh, doggone it, I never stored that angle yet. All right, I will start off and I will store it, and I'm going to call it U. So before I get going, I will make that angle U, and then plug this in. All right, when I ran that through, I got AB to equal 410.76. Now, that's an official answer that they want, 410.76. AB, so I would write that in one of those lines. And I'm going to store that as something because I might end up needing that. I'm going to store it as T. That's what AB is. All right, now, the next thing they want us to find is BC. That's this length right here, BC. I have a feeling you could figure that one out. Why don't you take a moment and go find BC for me. All right, so hopefully you did a law of sines problem with that because you knew these opposite sides and you were looking for this one, but you knew that this together made an opposite angle. So you could have done a quick little law of sines to find BC. I got a 448.41. All right, last thing that we are looking for is BD. That's this one right here. So now what I'm thinking is I should probably be using this big triangle here because it's the one that I probably know more about. Remember, you got to know 3 things in this to find the missing parts. So when I look at this big triangle, maybe I'll go ahead and highlight it. Let's highlight it in red. So I know V, I just did that. I know V, I know Y. Okay, got that. I even know, okay, now I called it angle Z, but angle Z was only part of the angle. I need the full angle, so I could add those two together because they're both given to me. And I'd have 3 pieces of information. So I have what I need to do this. Now, typically when they give you 2 angles, what you're going to want to do is go find that third angle. So I'm going to go find the third angle up here. And then what I'll have is a matching set with this side V here. And so I could do my law of sines because I've got that matching set. And then I'm going to be doing Y to BD there is the other set to set up my law of sines. So let's go ahead and I guess since I'm on my last part here, I'm not going to mess with storing stuff because I'm towards the end now. And so to find BD, I'm going to have, well, tell you what. So I'm going to call this, I don't know what letter I'm up to, S maybe. I'm going to call this S, and maybe store, I'm not going to mess with it. Here we go. So it's going to be, well, I'm sorry. Here we go. 180, and I'm going to minus the Y, so minus alpha Y, and I'm going to minus alpha Z, and I'm going to minus the S that I labeled, but I'm just going to minus the 60. Be careful with this. It's 60 plus 13 divided by 60 plus 36 divided by 3600. I put that all in parentheses. So I have an 18.99 for my angle D up here. I'm going to do a quick store that maybe. All right, so here we go. Now that I have that angle, I can do V over the sine of that angle D that I just found should equal what I'm looking for, which is BD over the sine of Y. Let's go solve for BD. right, I got a 401.98. And that's the third thing that I need. There's my 3 answers for this problem. All right, so remember, this is the problem that changes every time. This is they'll have some kind of weird diagram. They give a scenario of what's going on, why they needed to find it, and you have to go find the missing parts. All right, have fun with it. Try another example. Get online and find another one of these. I have them in Google Classroom.